So this is Rhino 6. And the way to launch Grasshopper is either through the command here, right? So you type in Grasshopper, enter, or through this icon here. So Grasshopper already comes installed with Rhino 6. If you have a earlier version for some reason, you have to install it as a plugin. So you have to download it from a website and then install it. Yeah.
I think Rhino 7's out now, isn't it?
Yeah, Rhino 7's out now as well. It's moving fast. I mean, usually it takes what, like 5-6 years for them to launch a new one.
We only got the Rhino 6 licenses, what, like a year ago?
Yeah, exactly. Yeah. So the idea with Grasshopper is you control data and you flow data, right? And data can be anything. Data can be a list of numbers. It can be geometry. So you have a list of lines, and then you apply certain manipulations as you go, right? So this is Grasshopper. These are your main tabs on the top here, and everything from decoding spaces onwards, these are plugins. So I know I mentioned Grasshopper is plugin, but there's also plugins for Grasshopper. So you can think of them as plugins for a plugin, right? And everything's available on Food for Rhino. So if I go here and I type in food, the number 4, Rhino, this is where you access most of your plugins, right? So you can see there's Rhino plugins, so Rhino apps. There's also Grasshopper plugins here. So if we go in Grasshopper plugins, so we do here is just type in Ladybug, enter, and you can see here Ladybug tools, right? And there's instructions here of how to install everything, and this is what you want here, the latest version. So Ladybug tools 1.1, check your Grasshopper version. So if you have Grasshopper 5, this won't work. If you go back here, you can see this one works on Grasshopper 5. And this is the most stable latest version to download. Let's just draw a few boxes, right? So here, Alt and move if you want to copy things quicker, just like that. Just create a random kind of array of boxes for us to start working with. That's all we need now.
Just 9 boxes extruded, sorry, and capped.
Yeah, just extrude them and cut them. So draw a curve, select the curve, type in the command extrude curve, and then just extrude them. And then you want to select all your boxes like this. And then you type in cap. And caps, and what cap does is takes it from a surface to a volume. Yeah, or a breadth. Volume is more accurate. So just like this, yeah, just something we can work with. And I just want to give it kind of a surface here, so it's not floating in midair. And let's do something funky for that tower. So I'll just move this up, like this, rotate slightly, and then I use the command Loft. Select curves to Loft, so I just select this one, enter. That's fine, enter. Okay. And I want to cap this as well, so cap. Curve. But this time, rather referencing curves or points, we're referencing actual volumes and surfaces. So the container to do that is called a brep. So if you go in the params, I can see all the different containers here. So I can bring in a point, a circle, a curve, a line, a brep, a mesh face, the twisted box, geometry, fields. I can bring all these different kinds of geometry in from Rhino. Yeah. So what I can do here is a brep basically contains anything related to surfaces and volumes. So I can select a brep. I can select my context and not my main building. Yeah. So the buildings around my design. So I'll select these, right click, set multiple preps. And again, you can see Grasshopper tells us that they're already in by highlighting them in red. So here, yeah. And I want another one, so rep, just underneath it here. Right click, set one rep. So now this is my design and this is my context. And I'm just going to do one more for my ground plane. So right click, set one rep. So now the ground, my design, and my context, right? We can. So a trick to use always in Grasshopper is use this panel. So this is a way for you to know what's going on. So whenever you connect, so if I'm connecting this over here, you can see it's telling me there is 7 geometries that you've imported in. And you can see this is called a list. So list in index 0. So lists in Grasshopper and Python language, they always start with 0. Think of it as a kind of a ground floor, right? So it's always represented as 0. And then the first floor or whatever, but you can see. So it starts with 0. And you can see we have 8 geometries, right? Because it starts with 0, the index is 7, but there's 8 extra geometries. And if you can count them here, that's 8. So panel, you can use this for anything, right? You can use this here as well. It tells us there's another brep. Use it here. It tells us there's another brep. You can also use, if the geometry is similar, so a brep, if you use this for some nodes, sometimes it won't work because it thinks you have a brep, but if you connect it here, you connect it back, it tells you it's a surface. Yeah, and I can reference this. I can reference this in this way as well, but no, not this way. Sorry, this, and it doesn't work because I have volumes and it's not easily translated in this case. But here, because I just have one single surface, I can translate it easily. But anyway, that's the structure. Okay, so we've referenced these in from Rhino, right? So one cool trick is if you want to send this, if you want to send the file to someone else, so I want to send this to you, right? I can't just save this Grasshopper file and send it to you because all my geometry is referenced here. Yeah. So this Grasshopper file won't work anywhere else. So one way of me translating all that geometry permanently into Grasshopper, so it stays saved as a piece of data in Grasshopper, is if I right click and click on this command, internalize data. This one here. And I'll do this for all 3. Internalize data. Internalize data. You can see if I click, this turns green again, right? This turns green. Yeah. Whereas initially you saw if I deleted the original curve, the whole code will not work, right? Okay, let me just do one more so I can show you what this means. So if I right click, that one curve. Okay, so I've internalized these 3. Internalized meaning saving the data in Rhino in my nodes, so they're contained within my nodes. And this one is just referenced. So now if I delete all these, click on this, you can see I already have the geometry, despite the Rhino geometry not existing at this moment because I've deleted it, right? But with this one, it doesn't exist. So you can see one locally defined value, null. I used to reference a geometry, but now it's gone. So that's the difference between internalize that we use here and just referencing something, yeah? So I hope that's clear. So let me delete this. I don't need this. I'll just save this. Okay, so with Ladybug, so you should all have it installed. So if I go on the tab for Ladybug, should have its own tab. You can just see all these tools, right? So every single tab has a drop-down menu. There's no way you're gonna use all these tabs and know exactly what all of them do, right? I mean, the list is pretty much endless, and with every update, you get new nodes and everything. So before downloading a plugin, it's worth researching it. What can it do? What it can't do? And then knowing what you want to use it for. Yeah. So Ladybug tools combines different combines the different families of tools. So butterfly, ladybug, etc. But the whole package is called Ladybug Tools, right? And what Ladybug Tools do is you reference an EPW file. I forgot what the acronym means, so if I just Google it, EPW file, environmental. EPW here, I think it's energy. EP, energy plus weather. Yeah, energy plus weather data format. Yeah, so that's what EPW means. And it's the data format to store environmental data. So where the location of the sun is throughout the year, what kind of temperatures were recorded throughout the year. Yeah, and all that, all those kind of stuff. So this is a file that Ladybug works with. So first thing we need to do is access that file to do any sort of environmental analysis. So if I go on here, click on this one. This is called, so if I hover over, it says Ladybug download EPW weather file, and that's what we need to do, right? So this is a very handy tool. So if I hover over the input, it's asking for, if you read the main the sub headline, it says set Boolean to true to open the EPW map page. So a Boolean is a different form of data. So if you've done a bit of programming, you know what a Boolean is. It's a true or false value. Yeah. At the moment, it's false. So what's telling us it's asking it to trigger. Yeah. Where the pop-up is asking us to trigger it. So we need to give it a true value. So if I just type in Boolean toggle. If I link this, nothing happens because I'm giving it a false value, so I'm not telling it to do anything. As soon as I turn it into true, you should get a pop-up straight away into Chrome. Yeah, and these are all the files in the world that you can download related to weather. You can see some of the locations. You can get remote locations like south of Libya and some random place in Russia here if your project's here, right? But what we want is the Manchester file here. So you zoom in and you get the one that's closest to your location. Any of these around here are effectively the same, right? Because the distance doesn't matter, doesn't change the climate much. But you want the closest one. So all you have to do is just click on this one, download. And I think it will download as a zip file. Download the Manchester one. And then what you need is the import. Yeah, so this is the important part. So Ladybug open this one with the file URL, working directory. I don't want this one. I want this one. Yeah. But there's two different ways, right? There's a way of linking it straight to some kind of data available online, and there's a way where you can download it and then access that information. It's glitchy sometimes. So if you go on copy link to clipboard,
yeah,
and just open a new tab and paste it, enter, it should come up straight away like this. Right. Okay. So we have the file downloaded. It'll download in a zip file, so you have to extract it. Yeah. So I don't have it here because I've deleted the zip file, but it'll be something like this, right? Show it as zip. You right click, extract all, and then you'll get this file. GBR, England, Manchester, Barton. So if you double click on that, you can see we have the EPW file here, and this is the file we need. Yeah. So now the next stage is about importing it into Grasshopper. Obviously, because any environmental analysis, you need to know what the local conditions are, right? So this is what we're downloading here. So if I go on the open weather file node, this is very similar to the one that we just did now. All it does, it triggers something in your computer. Yeah? So the first one triggered to open a Chrome web page, this one will trigger to open your file explorer to load something in. Yeah. So all you have to do is navigate to wherever you saved your file. EPW open. And this component here, import EPW, this every single Ladybug script will have this at the beginning. And what this does is takes this file in its raw format and then parses it and breaks it down. So we're able to work with it. Yeah. Why is this not working? Okay, it's working now. If it's not working, just connect it a few times. Okay. Right. So actually, before that, I want to show you something really cool. So all these components were developed by a single person. He's of Iranian descent. I forgot his name. And all these, you know, we work with Grasshopper. We're not entirely sure what goes on behind the hood, right? Or with Grasshopper tools, because they're coded in Python, and they're not exported as some kind of encrypted kind of codes. You can actually access all the code that's in Ladybug. So if you just go in any node you have here, double click, you can get all the Python code behind it. So if you're wondering why do you need to code, I think this is the best way to demonstrate coding is useful for architecture and architects. I know this all looks like gibberish, but it's worth, once you know how to code in Python, it's worth having a look, see if you can figure any issues that you can improve and then fix the code or whatever. You can improve the version of Ladybug. But it's with everything you find here, right? If I take any random one, double click, this will come up again. So if I take a panel, and I can start getting different pieces of information, right? So the file that I selected is a latitude, there's a location, so site, Manchester, Barton, there's a longitude and latitude. You know, I can start understanding what this file contains, yeah? Right, so now we have a breakdown of that file. And this is where we can start doing stuff. So we have all the data that we need, we have the geometry that we need, and we can start thinking about how we can use it. So the first thing, these, just to mention, all these tabs are separated in a very useful way and in categories, so it helps you kind of think about what you need. Sometimes you don't know the thing off by heart, so if you double click on the canvas, you can search for something. So if I look for a curved container, I can find it, right? Sometimes you're not entirely sure what you need. So if you look through these, you look at these names and you drop down, drag them in, look at the inputs, look at hover over the middle, it tells you what the component does, and look at the outputs, so it gives you a certain thing, yeah? So this is how you'd find out what you need, in addition to online resources. So if someone done something similar to what you do, how can you take that and maybe develop it again or do your own thing, yeah? And this is how you learn, really. There's no other way of learning apart from just keeping up to date with what people are doing and trying things yourself. There's no book on how to design this for your specific project and your specific thing. Anyway, so we can first, what we can do is visualize some of the data. Yeah. So the Ladybug sun path. This is a 30-second exercise, and it's a lot better than drawing a sun path diagram. So it's faster than drawing a sun path diagram in Illustrator, and many more times effective, right? So I'm just hovering over, you can hover over here as well, it tells you what it does. So use this component to make a 3D sun path in the Rhino scene. The component also outputs sun vectors that can be used for sunlight hours analysis. Perfect. Okay, so once we bring in the code, bring in the node, you can see that some of these Ladybug nodes are just massive. You can see all these different kinds of inputs that you can give it, and you can see all these different kinds of outputs. So a few things make sense, right? So there's a north. Of course, if you don't know where the sun path is, you need to know where north is, right? So if you hover over, you can see it says one locally defined value. That means it has a default. And north in default. So if I go here on the top value in the top, the default is always in this direction. Yeah, up. And I don't want to change that. So if for some reason your north is a different way, this is when you have to change it. So we'll go back here. But I'll leave this. So a convention in Ladybug is you see all these underscores. They're not completely random. So you see one's on the right, one's on the left. Sometimes it has twos on either side. And this is not completely random. It's just a Ladybug convention. So if something has an underscore on the right, it means it already has a default value. If something has an underscore on the left, you have to provide it. Yeah. So this whole node won't work without you giving it. So for example, a location here. How can you come up with a sun path diagram without a location, right? Because latitude and longitude and the sun location matters, right? So if it has anything on the left, that means you must provide it. If it has on both sides, it means you can provide it. Yeah. So on the right is default, this is optional, and this is mandatory. And because our EPW file has all this information, I can just have the location and just feed it the location. And you can already see I already have an output. So I've satisfied all the requirements that I need for this single node to run. Yeah. So if I go on 3D, over here. So this is specific to Manchester. These are all the different routes the sun takes throughout the year. Yeah. South, north, east, and with degrees. So yeah, this doesn't contain any data. You can see there's only kind of one point here representing a sun location. But I'll show you why that is. Right. So let me bring this here so it's easy to work with. Input point here to change the location of the sun path. So of course I want two ways of doing this, right? I can bring this whole thing here. So by the way, the center point here, this is where the whole sun path diagram or representation thing is, right? So this is the location of it. And at the moment it's to 0, 0, 0. So again, a default value. You can either bring this here. I mean, it's good practice to draw or wherever you're modeling in the origin in 3D in the 3D space, right? But anyway, I'll just show you how to move it. So there's different ways of moving it. All I want to do is just create a point. So if I just create a point here, again, just create a container. So PT, right click, set one point, enter, and then I can just link it here, and you can see it's moved there. Yeah. So everything is very logical and flows as you know. You just have to satisfy whatever the requirements are for the inputs and the outputs. So sun path scale, that's quite obvious. At the moment, it's not covering most of our site. So this is a 1 scale. So by eye, I can eyeball it saying I want it 5 times the size. And I just link it. So sun path scale. You can see here, I'm just moving it so it doesn't get in the way. Right? Sun scale. So this is the size of the actual sun. It's not important at the moment. Analysis period. Okay, so this is the important part. So at the moment, if I hover over here, you can see that has 12 default value. So the hour 12, which is midday, the day 21, the month 12. Yeah. So what this is telling me is that this yellow circle here is at noon on the 21st of December at noon. Yeah. So I can feed it different values here, right? So one thing I didn't show you. So one way of working in Grasshopper is through lists, right? So if I want noon and then I want 1 o'clock, 2 o'clock. At the moment, this is just text. If I right click, multiple line, that means I'm creating a list. So I have a list with 3 values here. If I link it to hour, you can see now I have 12, which is this one, 1 o'clock, which is here, 2 o'clock, which is here. Yeah. So I'm creating a new output for every item in the list that I give it here. So this is one way of doing it. Another way of doing it is using this analysis period input. And the analysis period enables you to combine months and time intervals and days all in one easy way of managing it. So, and again, this is a Ladybug component. So if I go here, if I go on the Ladybug analysis period, click on that, it's asking me, basically with this component, what I'm creating a period, right? So from what month? So let's say I'm focusing on summer months because in winter there's no sun anyway, so I'm not going to bother with doing the analysis. Yeah. Anyway, whatever reason. So let's just say, I don't know, from March. So from 3, from date. This doesn't matter. It'll start from 0. It's not very important for us. So if I want it to start from the beginning of the month, I'll give it 15. From hour, that doesn't matter as well. I want all the day, all the hours of the day. To month, let's say I want it to 10. Yeah. And then this gives me, this already outputs a data format that, because it's developed by the same person, it knows that this data format just goes in here and it works, right? I don't have to make all these lists and manually change them. So if I just plug it in, I'll give it a few seconds, and you should see that there should be an additional sun at all these points, right? So these horizontal lines, they show you the trajectory of the sun and how it moves, and these vertical ones are the location, the different months, right? So the higher it is, that means it's a summer month. The lower it is means it's a winter month, because the sun is lower in the winter because of the Earth being slightly off axis. Yeah. So we're getting very deep into this, but everything has a logic behind it, basically, and everything is controlled through numbers. So nothing is random. Okay. So sun path diagram. Okay. So you can see that took 23 seconds to run the whole thing. Right. Okay. So now I have all these different forms of information. You can see the other data points that I have here include temperature. Yeah. And so one of the ways I can visualize something like this is if I take this data and map it to my hourly data. So let's just wait for that again. There you are. So here you can see these colors represent the value, the temperature at those points in time where the sun is, right? So when the sun is lower in the winter, you can see it's colder, and then when the sun is higher, it gets warmer. Yeah, you can see here, 27 degrees. That's the hottest. You can see these strips over here, and minus 1.7 was the coldest, and then you can find on the bottom, like here, right? So Actually, before that, let me show you how to do some radiation analysis. So if I go on environmental again, I go on Ladybug radiation analysis, put that in. It's asking me for geometry. So this is the design. So if you hover over, it's asking for geometry for which radiation analysis will be conducted. So this is my design, right? The tower in the middle. If you remember, we have it just over here. So that's what I bring in here into geometry. And it's also asking for context. So the surroundings. So I can just use that here, bring that in. Grid size, this is a very tricky input. So this always causes the model to crash. So the bigger the grid size means the more general your results are. So if you think of the tower as a grid, so the smaller grid, the more time it'll take to calculate because it has to calculate a lot more points, right? The bigger the grid, the less time it has to calculate the points. So it's about resolution. I think resolution is the right word there. So let's say I want a resolution of 10,000, so 10 meters. So a grid will be roughly 10 meters by 10 meters, yeah? I'm doing it this just to show you. Another one that you need is distance from base. With this one, just give it a 0.001 value. Just like that. It's asking where to do the radiation, basically. Don't do it 0 because 0 will crash everything. Just do it above 0. Okay, so let me just move this here. I can see that this one's also required, so selected sky matrix and run it. So with a lot of nodes in Ladybug, a lot of them have this run it, and it's very similar to this Boolean here. So with this, at the moment it's false, so if I hover over, it doesn't have value, but I need to give it a true for it to run. And I'm doing this on purpose so you can see it crashing. You can see the whole thing turns orange, right? And if you hover over here, this is where you get a hint of what's going wrong. So it says input parameter selected sky matrix failed to collect data, and we know it's required and we haven't given it. So we need to figure out how to satisfy that requirement, right? So what I need to do here is, if I type in selected sky matrix. Where is it? Somewhere here. Surface, no. Let me see. There is. Select sky matrix. And this is the output that we need. Selected sky matrix, and that goes straight into this over here. Of course, we need to satisfy all these, right, inputs. So I can just bring this up here. And what I need is the analysis period again. I can use the same analysis period, but let me just make it into 1 month so it doesn't have to crash. Yeah, so this is from September to October. I just want to connect this here. So again, analysis period is the period where I want to conduct the analysis, right? Cumulative sky matrix, that's a different component that we need to get out. So you see how I'm working backward with Ladybug. It's a good way to do it in Ladybug because you know where you want to get, you know what kind of analysis you need to do, and then you can just figure out how to get all the data that you need. So get cumulative sky matrix, there we are. So let me just move these so it's a bit clearer, just like that. Now I'll connect this here. EPW file. It's asking for the EPW file. I'll just feed it in here. Sky density and run it. So again, a lot of these, because Ladybug has the habit of crashing a lot, you always have these safety mechanisms. Yeah? So you run a component, you wait it to finish, then you run another one. And this is not typical to all of Grasshopper, by the way. It's typical to Ladybug. So I can do Boolean toggle. It's false. As soon as I turn it to true, it'll run. It'll take a second. They'll get a black console thing pop up, I think, in a second. So what this does is takes the raw data and changes it slightly, right? Manipulates it. So you can already see we already have some kind of output here. Let me go back. So we've got a sky matrix over here. We've inputted it here. We have this value, and this went straight into here, right? And if I hover over this, you can see I'm just gonna click on these and right-click preview off, so I hide them. But you can see here that we have some kind of outcome. I'm just wondering why it's all blue. Radiation analysis matches the button. See what kind of thing again. Oh yeah, that's working now. Yeah. So this is sunlight analysis. The radiation should be working fine now. If let's try running that again, so you can just see the difference between them. When you start off here, I'm starting off with the surface geometry, so it's something familiar with Rhino. As soon as you bring it into the nodes, there's a translation that happens, right? So it's translating the geometry, and sometimes that translation has a problem because the way they've coded it isn't necessarily the best. So with flat surfaces, it should work fine because it's easy to translate a mesh to a surface to a mesh, a flat surface. But if it's a bit curved or twisted, I think that's where the issue is. And there's ways around that. You can explode something and make it into faces and then put it in. But you can see here again. So this is my sunlight analysis result, and this is my radiation result. And this is the kind of the energy that the sun exerts on this surface. Yeah. And this is the amount of sunlight. So they're different units of analysis, but they're very similar in their outcome. It's just the value that's different. Yeah. Okay. So, if you select everything just pops up like this. If you go back, where is it? Ladybug. A lot of other stuff that you can do. You can do an isophist analysis here as well. So, an isophist is about views. So if I go here, I have a context, which is this. I have a plane. I'll leave that empty for now, and this is so I'll just do it 50 meters, so just like that. Radius, and then I just need to give it a point here in the middle. T for point container, set one point, this one, and then I'll link that. Let's make sure everything is when you begin with very crude resolution, so you work with everything, make sure everything works fine, and then if you need, you can make it higher and then wait for it for whatever, half an hour if you need for it to process everything, and then you can just export your results. So it's very effective. There's so many different tools, different ways you can analyze. You can see there's also okay, so just to show you here, so this component basically takes a point, which I've given it in the middle. It takes your context, So this information here. So this is the point in the middle context, and it maps out the views. Yeah. So you can see from this point, you can see all the way through here, and it gives you this kind of nice visual output, which you can just right-click, bake. Yeah. Okay. And that's already diagram effectively. So right. So it's already diagram already there with all these different views that you can get. That's worth the 3-minute wait. So let's get rid of this before it runs again and have to wait again. See, these are the surface of the Isomist. So many different nodes for Isomist. The Ladybug is not the most effective one. There's a lot of different ones you can download. Very, very popular tool. You can see calculating renewables. I haven't used these personally, but let's say you have a building with photovoltaics. You can calculate the amount of energy your photovoltaics will generate, and then you can use it to actually demonstrate your building is sustainable. Yeah, whatever. Water, temperature, heating, all these kind of stuff you can use here. Environmental analysis. You can look at all these different things. So set sun, view analysis. This is the one that we just used now. View rows. Forward tracing, so how light bounces. So let's say you have a particular feature that you're designing where you want to bring light into your building. Tells you there, use this component to get a sense of how sunlight is reflected by a set of context geometries by tracing sun rays. Yeah. So light rays and how they bounce around. As I showed you, sky dome, all these kind of stuff. And whenever you want, let's say you want the windrows, you just drag it in, figure out what you need. Okay, I know I want the windrows. I know I have to find this hourly wind speed. And then you have to figure out where you're going to find it, right? So I'm not entirely sure what this hourly wind speed thing is, to be honest. But Ladybug wind profile, is this it? Wind speeds, there we go. Yeah, so this is the one. And again, making sure everything's linked over here, and I link this here, and then I get the outcome, effectively. Yeah. Shading, all this other stuff. So I hope that's useful.